Hello and welcome to a video on identifying like terms. So here we've got an expression, and in this expression there are 5 terms. So you could think about these as different items. So for example, I like to use the analogy of fruit and vegetables. So we could say we've got 4 apples plus 2 bananas plus 3 carrots plus another 3 bananas plus another apple. So we've got 5 terms in here, but I want you to think about how many are like terms. Now what we mean by like terms is terms that basically look like each other. So we've got 4 apples here. Let me just circle the 4 apples. Now, are there any other terms that involve apples? Well, yes, there are. If we look right at the end here, we've got another apple. So we had 4 apples. And now we've got another apple, so in total we've got 5 apples. We would call these 2 terms like terms. And with like terms, we can add them together. So if you've got 4 apples and we add on another apple, well, we've now got 5 apples. So we've got 5 apples in total. Now if we have a look at some other like terms, well, here we've got plus 2 bananas. And remember, whenever we're identifying terms, we always include the sign in front of that term. So we've got 2 plus 2 bananas, and we're adding on another 3 bananas. So in total, you can probably see we've got 5 bananas in total. These are also like terms. So if we add these together, that gives us 5 bananas. And finally, well, we've just got our 3 carrots left over that we haven't included yet. And there are no other terms that are like this term here, so we can just add that on at the end. So we've got plus 3 carrots. So what I've actually done is I've simplified our expression. So I've gone from 5 terms to now only 3 terms. And what we call this is collecting like terms. So like terms are any terms where the letter, or we should say the variable, is the same. And if terms are not like, so for example these 2 terms at the front, we would call them unlike terms. Now here's a little conundrum for you. I would like you to think about, are these 2 terms here like terms or unlike terms? Now the answer is that they are unlike terms, and I'm going to explain why. So let's just imagine this is 4 centimetres. Let's just say the A represents centimetres. So this is 4 centimetres, and we are adding on 4 centimetres squared. We're adding on 4 centimetres squared. Now, can we add on 4 centimetres squared to 4 centimetres? Is that possible? Does that make sense? Let's just draw a line that is 4 centimetres. Let's just say that is 4 centimetres. And we're going to add on 4 centimetres squared. Well, what would that look like? Well, if we've got something that's 4 centimetres squared, we could draw a 2 by 2 square, which is 4 centimetres squared. So we could draw a 2 by 2 square. So this is 2 centimetres times 2 centimetres, which gives us 4 centimetres squared. Now, can we add these 2 things together? Well, no, that just does not make sense at all. We can't add a line to an area, or we can't add a length to an area. If we had 2 lengths, we could add them together. So, for example, if we did have 4 centimetres here, and then let's say we had 2 centimetres here, well, we could add them together and that would give us 6 centimetres. We just add the 2 lines together, we just get an even longer line. But we cannot add a line and an area together. That just is impossible. So these 2 are not like terms. So even though the variables are the same, that doesn't necessarily mean that they are like terms. It all depends on what this number up here is. So this is called the index. So here we've got a squared, and here we've just got a to the power 1. Okay? If there's nothing there, we just write 1. So we've got different indices, so they are unlike terms. They are unlike terms. So what I'd like you to do now is pause the video and see if you can identify from all of these terms on the screen here, all of the terms that are like 6a. So which ones are like 6a and which ones are unlike 6a. Okay, so I'm going to go through them now, and I'm going to use green for like and blue for unlike. So let's start at the top here. So 1.7a, is that like 6a or unlike? Well, the letter or the variable is a here, and the variable here is also a. So these two terms are like. They are like terms. Now let's have a look at this one here, 6ab. Well, our variable, or we could say our variables, here we've got ab. So it's not a. Remember, it just has to be a. Just one lot of a. So this is unlike. So I'm going to give that a blue cross. Now the next one is just the number 6. Well, these are unlike terms. We do not have any a terms here. So if we're thinking about a being apples, we have no apples. We've just got the number 6. So that is unlike. Here we've got 2a. So that is definitely like 6a, because we could add these together. 6 apples plus 2 apples is 8 apples. Okay, and just, you might be wondering, well, you can't have 1.7 apples, and you are correct, but this doesn't necessarily need to be apples. We could think about a as being centimetres, like we said before. So 6 centimetres plus 1.7 centimetres, that would give us 7.7 centimetres. So we can add them together. Okay, this next one. Well, we've got a, but it's not a on its own. It's a squared. So the index is different. So these two terms are unlike. Here we've got minus 3a. And again, the variable is the same. So these are like terms. And again, we could think about it as 6 apples take away 3 apples. We're now left with 3 apples, so we can add them together. Let's now go on to this one over here. So again, we've got a squared, so they are unlike because the variables have different indices. And the same here, we've got different indices, so they are unlike. This one here, they are like because we've just got the a on its own. Here, well, we've got a cubed here, so this is completely different. So this is unlike. So let me give that a blue cross. We've just got a on its own, so that's just the same as 1a. So that is like 6a. So let's give that a tick. And minus 6a, that is also like terms. They're also like terms because we've just got the 1a. And exactly the same here. Although we've got a long decimal, we've still just got a. So these two terms are also like. So how did you get on? Did you get them all right? If not, just have a look to see where you went wrong. And we're going to use this in the next video. So now you can identify like terms. In the next video, we are going to be adding and subtracting like terms. I'll see you then.